This is the embedded 7th semester CS course. Our project is an LED cube, a 6x6x6 cube. We're calling it the iCube because it's better than all the other cubes. Our cube basically consists of 214 LEDs. We've all worked on the same project for about a week now. Technically, we all know all the aspects about the code and the hardware. However, each one of us will walk you through a different part of the code. I hope you enjoyed this video. Okay, so let me first walk you through how the cube itself was built. First of all, we got some sort of foam or block of wood or anything, and then you put a grid on it. The grid, we put a distance of 2 centimeters between each hole, and then you put a hole in it according to the circumference of the LED. This is only to form the shape of the cube. After you fill it, I will demonstrate how you solder each LED with the next one. We bend the LEDs themselves to form the cube. We have in every LED there's the anode and the cathode. The anode is the long one and the cathode is the short one. You bend the anode towards you in the 90 degrees, and then you flip it. Then you bend the cathode on the other side. Then you flip it another 90 degrees. After you get this shape with the LED, you start putting it in the grid that you drew in this position. Then we'll show you how we did the rest. After the cube is done, the anodes of the LEDs are connected to each wire. This represents the layer, so each level here connects all of the layer together. And then from the bottom there are 36 cathodes remaining. The 36 cathodes connect each column. So if we want to light one LED, which is, let's say, this LED, we light up the first layer and the first column, and then we get this one only lit up.
Now I'll show you the connections between the cube and the Arduino. The cathodes of all the LEDs in the bottom layer are all connected with wires that are connected with the breadboards. Each row has a color to avoid confusion. This is row 0, 1, 2, 3, 4, and 5. Each layer has a corresponding transistor. The transistor is used to amplify the power, and each transistor has 3 pins. One pin is connected to the ground of the Arduino, and the other 2 pins are connected, one with each layer in the cube, and the other is connected to the Arduino. Each row from the bottom layer of LEDs are connected to 6 input pins, starting from 0, 1, 2, 3, 4, and 5. And here are the input pins for the layers: 0, 1, 2, 3, 4, and 5.
Okay. Here's the code which controls the iCube. At first we set the pins on which the rows and the layers are connected to. The method setup is called only once in the code, which is used to set the pins, set like the configuration of the cube, set the pins for output, and set all the pins to high. And then we have the loop method, which is called continuously throughout the which is called continuously. How we basically control it is that the whole column is set to be off with like a low input, and the only layer we want to switch on is set to high, and basically that's the only bulb, the only LED that turns on. We have 3 loops, one that loops on the rows, the other on the layers, and one on the columns, and by controlling each of them we set to low and high. That's how we control each LED alone, or we could control a whole layer by itself, or a whole column, or whatever we want to set. That's how we could generate different patterns or whatever.
This is the USB shield. It connects over the Arduino. It gives you extension for the pins, and also gives you another port for USB so that you can connect anything over it. We use it to connect an Android phone so that you can control the iCube on and off. The code was divided into two parts. One part for connecting the Android phone with Arduino. So you can see that here you've got that you initialize the USB. Then you got you call the task for the USB, and you see if the Android development kit is ready. Then you start accessing. You start the program. Else you do not start. That's simply the code for the Android.
Thank you for watching this video. It was really fun making this project in spite of all the difficulties. To sum the project up, I just want to say that it's not just a cube, it's the iCube.
It's the iCube.
It's the iCube.
The iCube.